Okay, example 2, we are going to find the limits of these polynomial functions. So this becomes 3 squared because we have the x here. This is our c. Plug in the c value for x. Put a 3 in x's place. Times 2 minus 3. And this is 9 times negative 1, which is negative 9. The limit of this function is, or as x tends to 3, is negative 9. Okay, part B. Same idea, taking this 2, which is in C's spot, and putting it in for every single x. So this limit as x tends to 2 is 2 squared plus 2 times 2 plus 4 over 2 plus 2. So we have 4, 2 squared is 4, plus 2 times 2 is 4, plus 4, over 2 plus 2 is 4. Don't cancel any of those 4's out. You cannot cancel when you have plus signs on top. 4 plus 4 plus 4 is 12, divided by 4, and this gives us 3. So our limit as x tends to 2 of x squared plus 2x plus 4 divided by x plus 2 is equal to 3. Example 3. Determine the limit as x tends to 0 of tan x divided by x. So this is a little bit different than what we've looked at so far because you do have that trigonometric element. So what I'd like to do first is look at the graph of this. I'd like to try to determine the limit graphically. So I'm pulling up my y equals screen and putting in tan x, close parentheses, divided by x. I'm going to adjust my window. Let me just make sure I'm in radian mode. Okay, I am, and I messed this up a little bit. Okay. In my window, I'm going to make my x min negative pi, x max pi, and x scale, I guess, pi over 2. Yeah. Y min, let's do negative 3 to 3, y scale 1, and graph it. Okay, so here's our graph. We're trying to find the limit as x tends to 0. X is 0 around here. Let's see if we can trace that. Oh, and I hit the trace key, and it's showing that at x equals 0, y is undefined. So let's just trace around it a little bit and see what y looks like it's getting close to. So as I get closer to x equals 0, it looks as if y is getting closer to 1. Okay, it's not exactly 1, and I can't just plug that value in because, again, if you plugged in a 0 for x there, you would divide by 0. The graph is not defined there. So I'm going to have to do this analytically. But graphically, it looks like this is going to equal 1. So this is from the graph. Okay, but we need to confirm this analytically. And we're going to do this with the limit rules, but we're also going to use some trig identities that you should already know from pre-calculus. So let's give this a go. Okay. From pre-calculus, you know that tan x is equal to sine x divided by cosine x. So sine x divided by cosine x. And then divided by x is the same as times 1 over x. But I want to rearrange this a little bit. And I can do that. I can swap the x and the cosine x. Okay, so the limit of sine x divided by x as x tends to 0 is 1. That is a very commonly used limit that you should be familiar with. So this one is equal to 1 times, and I'm breaking this up using the product rule. So times the limit of this. So we can go ahead and plug in that 0 for x. Cosine of 0, you should know again from pre-calculus your unit circle. Cosine of 0 is here, and that is equal to 1. So this is just 1 times 1 over cosine 0. So 1 times 1 over 1, which is 1. So analytically, we confirmed what we suspected from the graph, and that is the limit of the function tan x divided by x as x approaches 0 is equal to 1. Example 4, this is the last example in this video. Use a graph to show that the limit as x tends to 2 of x cubed minus 1 divided by x minus 2 does not exist. So let's pull the graphing calculator up again. Clear this out. So parentheses, x cubed minus 1 divided by parentheses x minus 2. And I'm just going to do the standard window, so zoom 6 will bring this up for me. And did I put this in correctly? Yes, okay. So if we trace on the graph, I want to hit trace to enter. I see that there is no y value. So I'm thinking that there is no limit here. There's nothing on this other side of the asymptote. This line here is the asymptote. Let's look at the table. So second graph brings us to the table. And you see that there is an error at y for x equals 2. So, yes, that would suggest that your limit does not exist. And notice also that if you took this 2 and plugged it into the denominator there, that you would have a denominator of 2 minus 2, which is 0. And again, you would be dividing by 0. So you can't do that. Therefore, the limit does not exist. So that is it for this video. I will see you again in part 3.